In class activity 15b, 1, consider the rational functions m of x equals 3x squared plus 12x over 4 plus x squared, and n of x equals 3x squared over x squared. Part A, how are the two functions related? Well, they're related because they have the same leading terms. So what we're thinking about here is the highest degree term in the numerator and also in the denominator. So if we were to write that, we would write 3x squared over x squared, which is actually the n of x term. So this value here and that one there, that's what they have in common. So for part B, graph the two functions in the same window. What happens for large values of x? So I open up the calculator and I have this already set up and we're going to graph it. And if we graph both of them, we can see for large values of x, whether they're large positive numbers or large negative numbers, that the graphs get closer and closer together. We can even expand the graph and make it look, you can see more x values there. And you can see the graphs are getting pretty close together. Let's go back to writing. Objectives for the activity. You'll understand how the leading terms in the numerator and denominator affect the behavior of irrational functions, and you'll be able to describe the behavior of a rational function for large input values. This activity will use the model for effective population size presented in preview assignment 15b. And that's listed right here. N sub m is the number of breeding animals in the population, and n sub f is the number of breeding females in the population, where n sub e is the effective size of the population, which approximates the number of adults in the population that will contribute to producing genetically diverse offspring. Part 2, suppose a population has a single male. Determine a formula for the rational function that describes n sub e in terms of n sub f. Well, if we only have a single male, that means we're going to have n sub e, we'll have a 4, and then the males is just going to be a 1. That means we're going to have a 1 in here, and then n sub f over 1 plus n sub f. We don't really need to write the 1 in the numerator, so that could actually be 4n sub f over 1 plus n sub f. Part B, identify the leading terms in the numerator and denominator. What do you think the effective population will approach as the number of females in the population increases? Well, if I identify the leading terms in the numerator and denominator, and we identify, or we find out what the population increases to, if we think about this, we have 4nf, and then we have nf here. These are the leading terms. Those can cancel, and we're left with 4. So it looks like the effective population will approach 4. And if we were to graph this, oops, we would get a graph. Let's see. All right, and let's go and graph this. I have this entered into the calculator on the y equals screen already, and we'll graph it, and it would look like that. So the population, it's going to approach 4. You can see 4 on the y-axis. Both curves, approach that as you go farther to the right and farther to the left on the graph. They're approaching 4. So let's go back to writing, and if we were to graph that, and the graph went something like that, and then it came down here and went something like this. And then that would be y is equal to 4, that dotted line. So part C, it says graph the function you found in part A. Was your prediction from part A correct? And we can say yes. Part 3, I'm going to move this up here so we can see it. Suppose a population has 3 more males than females. Part A, says determine the formula for a rational function that describes this situation. Well, let's see, we could write n sub e is equal to, we have 4 more, so we could write 4 and then nf plus 3 times nf, and then we have n sub f plus 3 again there, plus nf. We're just taking the number of females and adding 3. There we go. Part B wants us to simplify the expression that we just wrote. So why don't we write this as 4 times that, we get 4. And squared plus, it'll be 12 n sub f over 2 n sub f plus 3. Okay. Part C, identify the leading terms in the numerator and denominator. What do you think the effective population will approach as the number of females in the population increases? So the leading term in the numerator is that right there, the 4 n sub f squared, and the leading term in the denominator is the 2 nf. I just circled both of those. So the population should increase without bounds. Let's try this. Okay, so if we graph this, and I have this entered in on the y equals screen, let's go there, and we'll graph it, and it looks like that. And it says graph the function we found in part A. Was our prediction correct that it would increase without bound? And it looks like yes, it will. So let's go back here. And on the curve, we're supposed to graph this here. And we did already on the calculator. So let's go to part 4. And it says consider the function defined by the following formula. F of x equals a times x to the n over b times x to the m. Part A, pick positive values for both a and b and write them down. You'll use these values on all the remaining parts of this question. If we just pick, it says pick positive values for a and b. So why don't we just take a, 5, and we'll let b be 2. So there's 2 values, 5 and 2. Part B, choose values of n and m so that m is larger than n. Graph the rational function. What happens to the function as x gets larger and larger? So m has to be larger than m. So why don't we do m is 3 and n is equal to 2. So there we go. 3 is larger than 2. So we have to graph this next. So let's go to the calculator. Okay, so if we graph this, I have this on the y equals screen, and we graph it. We get a picture that looks like that. So let's go back and fill that in on our graph. Like that, and like that. So next, part C, let me scroll down here. It says choose values of m and n so that m is less than n. Graph the rational function. What happens to the function as x gets larger and larger? Okay, so I have an example of this graph already here. Let me go ahead and turn off the first graph, and the second one is on. This time we have a graph that looks like this. So let's go back here. There we go, like that. And part D, it says choose values of m and n so that m equals n, and graph the rational function. So if we go ahead back here and look at what this graph would look like, it looks like a horizontal line. So we can go ahead and graph that. There we go. And that is the end of this lesson.